My name is Luã. So today I'm going to be talking about dependency inversion. So I'm going to talk about four concepts, four things. The first one, dependency inversion, dependency injection, inversion of control, and dependency containers. They're all like kind of tied together, and I'm going to try to explain each one of them individually and how they tie together. Cool. So this is me. I'm from Brazil. That's why the weird accent on my name. I'm a lead engineer at the Iconic, and we do lots of PHP at the Iconic. And I'm wearing the same jumper in the picture. We're hiring. We're probably gonna announce something later. But if you need to know more about the Iconic, just talk to me in the break. Yeah, we have plenty of PHP jobs open. Cool. So why should you care about all those things I'm talking about tonight? So all those concepts, when you apply them, they help you to decouple your code. They promote more clean and reusable code base. You're applying solid, so you focus on single responsibilities, so you can apply the dependency inversion in some of those concepts. By doing that, your code becomes more reusable. And the key benefit for me is like testing, so it helps a lot with testing, and it also helps you to abstract your code into logical components. So yeah, let's start. The first one I'm going to talk about is dependency injection, because it's probably the one you use the most, like from your day-to-day. I'm pretty sure if you use any framework, you're going to be doing a lot of dependency injection. You might not care about the other principles and just focus on this one on your day-to-day job. So dependency injection is all about like how one object knows about another one that depends on it. So it's not about how your class knows about your dependencies. But I have a simple class here. This is a simple command class with stats dependency there. Anyone know what might be wrong with this class? No? Yeah, so you need a new stats structure right on that, just here. And there's a problem with that, because you're kind of gluing your instance of the dependency to your code. So we're going to see in a while why this is bad. The whole goal of dependency injection is to separate the creation of your dependencies from the behavior of your class. So the methods that are tied to the behavior of your class shouldn't care about creating the dependencies. They should just use them. There are two types of injection, ways that you can achieve dependency injection. And the first one and the main one, I would say, is through the constructor. So how you use it, I'll go back to our class. So this is the base class again, and there's one small difference here, which is the dependency, instead of being created in the main method, the behavior of the class, it's being injected through the constructor. And this type of injection is mainly used when you have a required dependency, when it's mandatory to have a dependency in your class, and it wouldn't work without passing a valid instance on the constructor. The second type of injection is the setter injection. So there's one small difference between constructor and setter injection. Is you can use either, but I would say that the setter injection is best when you have an optional dependency. So the constructor is always going to require the instance, but within the setter, you might call the setter, or maybe you're not going to call it. So this is how it looks like. You have the same command class, you get a logger, and we are just creating a set method, and you're passing your the instance through this setter. And this is how usually we use something that's being injected through the setter. And you never know if the setter has actually been called or not. So you might have to check if the instance is there every time you use a dependency. And if you really need this instance and you need to use it all the time, it might be annoying to keep checking if the instance is actually there or not. So that's why I use the constructor injector when it's mandatory. There's another way of doing injection, but we don't use it quite often, which is the property injector. You would have like a public property, and you use it to assign a new instance, but yeah, we don't usually do that. So I think the key benefit is unit tests. So how do we use dependency injection to help unit tests? Back to the sample class, we have the first way, and again, like something is wrong with that, and it's specifically bad when you think about testing. Any guesses why? Sorry? It's not unit testable. Okay, it's not unit testable. So why it's not unit testable? Because the way you would test a class like that is you don't want to test your dependency. And if you're creating an instance of the dependency inside your behavior, you have zero control about that instance. And you're always going to have a real instance there. So when you're using the constructor to inject your instance, you can just mock the dependency, and you're not actually fetching anything, you're not going to the database, or not doing anything that your class is not supposed to care about in the unit test. So kind of done with dependency injection. Moving on to the dependency inversion principle. So this is it's principle within solid. So if you know solid, that's the D up here. And this is like the base definition of solid. So if you know it by the book, you probably know how to recite this. And I think that's a lot. So the gist of it is you should depend on abstractions and not on concretions. And let's try to see what that means. So your class shouldn't care about the specific implementations of the dependency. Instead of using like a concrete class as for instance, the type hint of your dependency, you should use an abstraction of that class. How do we achieve that? So what are the options that we have to achieving the abstraction of the type hint? So the first and probably most used one is interfaces, where you can create a contract for your class. You don't care about the concrete implementation. So in this case, I'm doing an adapter for like a carrier integration. You don't care if you're using sorted post, DHL, or anything. You just care that you're using a shipment adapter, and it's got a create shipment method. So if we check the implementation, the change here is that you're depending on the interface there. So whenever whatever instance you pass, like a concretion that you pass, it's going to work here. So that's like a basic way to cope with this principle. So does it mean that every class needs to have an interface? So no, that's a mistake that can happen in some occasions. Like if you try to be really solid and follow the principle like by heart and be really curious, and you end up creating like this on PHP Storm, you have like one interface, one class, and you follow that everywhere. There are other ways of achieving that, and probably the most obvious one, apart from interfaces, are abstract classes. They do pretty much the same around the abstraction. So I'm getting like this abstract class here as an example. So just basically to have an abstract method, you have the constructor there. And so if we use the first class that I showed here, the command class, I was depending on a concretion here. I have my stats fetcher. So maybe I don't care about the stats part, maybe it can be something else. And the change I would make is depending on the abstract fetcher instead. So you stop depending on the concrete implementation, and you depend on the abstraction. So there's something that I always try to keep in mind when I'm talking about the dependency inversion principle, and this is this other principle here that's kind of it's related to solid as well, because it says that you're not supposed to be creating stuff that you're probably not going to need in the future. And we tend to do that a lot, like let's just abstract everything because we should not depend on completion, we should always depend on abstractions. And you're creating interfaces all over the place too, because you need to depend on that. And maybe you're not going to need it. So, like, is it really wrong if you don't have to create an abstraction for that? And that's a bit controversial if you're like a solid theorist. You can also depend on a base class, and the base class might not be an abstract class. It might be a concrete class. For instance, let's say you have like a different client just calling something in the API, and sometimes you get like a vendor code that has a client because you don't want to write the API integration by yourself. And it's a concrete class without an interface. But you know you're always going to be using that thing. So is it really worth it to encapsulate it somewhere just in order to keep your code like really solid by the book? Maybe not. Maybe you're always going to use this library and you're always going to call this method. So if someone wants to do something, extending that, they might just use inheritance and extend this concrete class, create another one, and keeping the same method as the parent class, the base class. Yeah, it was my example of using like a simple class and type hinting that with a base class in the concrete implementation. So two things that I wanted to highlight with the dependency inversion principle. One is a dependency should always be replaceable without any changes in your class. So your implementation shouldn't have to change one line of code if you decide to make a change in your dependency or to replace it with something else. So that's why I use this principle. The second one is, please, like, keep in mind, like, open heart. Use solid, but also think about this other principle here. Yeah, maybe you don't need to abstract everything, and you're not going to waste a lot of time trying to create interfaces everywhere for everything. Cool. So this brings, so we covered dependency injection, dependency inversion. Now we go for inversion of control. It's a simple concept, but it's really tricky to explain. I thought about it like many times on how can I explain that through code, and on a different way than I'm explaining everything else. So there is a nice comparison with that says that it's a hardware principle. So it's all about you don't call us, we call you. So what does that mean in code? So usually it's applicable within frameworks. You can see like frameworks like React within UI frameworks. You have an event, and you don't say that button that you're clicking is actually sending an email. Just trigger an event on the click of the button, and somewhere in your application you're gonna grab that event and call an action. So within React, for instance, you have the concept of actions. And your actions have all the implementation, but they don't know when they're going to be called. They're there. Like you can use the action, you can use that code, but you don't know when they're going to be called. It's up to the framework to fire an event that's going to be triggered, and it's going to be tied to that action and then execute it. So you kind of pass the control back to the other side. It's also really used by dependency injection containers. That's pretty much what you do. When you implement a container, we're going to cover that soon. Event-driven architectures and maybe using the observer pattern. Mobile development's probably going to see that a lot. And I came up with an example here. And this example is like some dummy code that I usually do. I do something like that when I'm creating like a prototype, and you probably do it as well. So instead of creating your whole object or oriented object design and creating all the classes, you just instance everything on one index.php file, creates instances, pass them around, and then you run it, and it works. But you know that if you have this index.php creating instances for everything, like you have the control, you have complete control of all the instances of all the objects you're creating, but it's a mess. Like maintaining this kind of fairness, it can be a mess. So when you apply the inversion of control, you end up with something like this. So instead of having control of all the instances and how the methods are being called, you get your container, you get the main instance of something in the application, and then you run it. And everything else is going to be triggered by events, and you don't control how everything is tied up in there. So yeah, that's really all for it. The last one, it's the dependency injection containers. So how do the containers that we kind of use when you use a framework, when you work with a framework every day, using containers like Symfony, Fireball, and they all have either a dependency container or a service manager. They're a bit similar, but for the containers, it's pretty much a way of putting all your instances in one big place, and you have like a big box that stores all your dependencies, and you can fetch some stuff from within the container. Don't worry, I'm going to show some code to explain it. But how complex can be like a container, like a library? How complex is it? This is a tweet from like Fabian Potenzier, the creator of Symfony. It's from 2009, and he was really excited about some new features of PHP, and he decided to create a container that fits on a tweet. And it's a container. It works. Like if you test it, actually works. And it doesn't have to be that complex. So this is how I picture that when I'm thinking about a container and using my really core design skills. I think about a big box that holds all the instances that I need, and it also knows within my dependencies and their dependencies, how do they connect? So if one dependency is asking for another service and vice versa, the container just hooks all of that together without like me having to worry about how they tie together. You configure the container and it provides you the instances. So yeah, how does it work? I'm going to show a lot of code, and my idea is to tie together all the concepts within a container. So please try to follow that and ask some questions later. So I'm going to start with the index.php code, the one I was just showing on the inversion of control. So it's very simple. It's the entry point of your application, and you always need an entry point when you have a container. So you need to create a container, and then you get the root or the kernel or something in your application, and you run it. The magic here is that I'm going to get an instance of my command class, the same one I've been showing in the previous slides. And I really don't care about how this instance is created and how everything works within the container. So moving on. This is my command class. It's pretty simple. It's getting a repository here. It can be a repository of anything because I'm using the dependency inversion principle. So it just needs a repository, and there's a run command that probably uses the repository for doing something. This is my repository. It's also got its own dependencies, in this case a connection. So I get a database connection, and probably does some cool stuff with it. So I'm going to go back to the index.php. So now we know how the command class works and how the repository class works. This is my container.php file. So how do I create a container? I'm using Pimple. It's a really simple container library in PHP. I really like it because that's how you create a container. So you just a new container and you have a working instance. And whenever you need to create a dependency to create a service within the container, you just need to use the array access from PHP. You define a key, and you return a new instance wrapped around an anonymous function. So this is how we put one dependency in the container. And how can we use that dependency layer? So picking on the container.php file, you have the repository, the class that I just showed. Basically, we're creating the repository and we are accessing the connection from the container. This instance is already there. We configured it before, so you have access to it. And the good thing is that once the instance is there, you can use it multiple times. You can use it on multiple services. Maybe you have another repository, maybe you have a model, and you still want to keep using that instance of the connection. So this is the command class. And when you declare this class, and remember this is using that repository class that also has its dependencies. What the container does in this case is this dependency has been declared already, and it's using other dependencies. So whenever you access the container, the command instance, it goes to this one and creates an instance, and goes to the dependencies of this one and creates the instance, and maps everything together for you. So if you're declaring this command class, you don't have to care about all the other dependencies. You just get the one that your command class needs. So going back again to my index class, I'm getting the container.php with all those declarations that I have. I get my command instance and I run it. There are a few container libraries for PHP. The one that I just showed is called Simple. It's from the same guy from the tweets. After the tweets, I think he got inspired and created this library. That's why it's so simple. You also have the big brother version of the library, which is the Symfony dependency injection. It's really complete. It's got a lot of cool features. It can be used outside of Symfony. I put it together with Zen framework before. It was a bit of a nightmare at the beginning, but then it works and it was magical. You have the PHP DI, and I'm guessing from Laravel and the other frameworks you also have other containers, but these are the ones that I've tried before and I really like. So going back to the first question, so why should you care about all those principles and applying them on your day-to-day? You're going to write plain decoupled code, that's the first one. You're going to make things reusable, because when you put your instances all together in the containers and you're using the dependency inversion principle, so you can reuse your base class with different dependencies. Your testability here is key. So everything you showed in the slides, everything you do right, keeping in mind injection and dependency inversion, is going to be way easier to test. And the last one is that maintainable code is actually beautiful code. So yeah, quite an improvement. That's it. Any questions?
Okay, then I do. Oh, Miguel's there. Yeah.
Shout loud, Miguel, or come down.
Okay. So you talked about containers.
Yeah.
How do you manage, for example, multiple instances of the same key in the array?
Cool. So in that container library, they have a way of declaring private instances, meaning that whenever you require a new instance, it's going to give you a new instance. Whenever you require a service, it's going to give you a new instance. So it was like a bit simple. You have the anonymous function, and if you use the container class and you call a private method, you can have like a private service that's going to always return a new instance if you don't need to use the same instance over and over again.
If you were to reutilize the same instance, probably create that.
Yeah, that's what you do. The way I showed here is it's already reusing the same instance. Go back a little bit. Yeah, so with this way of declaring the services, it's going to always return a new instance. So the first time it's lazy loaded. So you have the anonymous function here. When you call it for the first time, it's going to return you the instance that you just created. When it calls you the next time, the instance is already there, and you're there, so that you don't have to create again this function.
Instead of just returning the same U1 all the time.
Yeah.
So my question would be that how does, for example, dependency on models, which are stateful, work with the container principle, in your opinion? Like, let's say that I have some kind of utility library that does operation on a set of models, let's say.
Oh, so when you say model, you just mean like an entity?
Yes, technically a DAO entity.
Yeah, so that's the case where the DU is not bad.
Yeah.
You can use the So 90% of the cases, I would say, using DU is bad. But when you have to use entities or DTOs or anything that's holding data that's stateful, it's representing something that might change, then you use new. You don't have?
Sorry, I also find yourself containers. So I don't find yourself containers. Like
I would say that I use it almost on every project that I have, because even with this case that I showed here is a command line based application, and it's simple. It's got one command, but I just don't want to be managing all the new and creating services by hand. So I use this library, which is really simple, and just by having the container.php and calling it that way, that's all you need. Like you can use it to have like a really simple container, and it's not adding variables or adding representation. If you have a look at the Symfony dependency injection, for instance, it might be way heavier. So we only recommend if you have a bigger application, and it's going to make more sense to have a lot of dependencies. If you have like 10 dependencies, this one is perfect. More questions? Okay, thank you.